I've got no roots, but my home was never on the ground. I've got no roots, but my home was never on the ground. I've got no roots. I've got no roots.
Assalamualaikum. We are from group PEC1104B2. Our current course is EC110. And today we will be present our project assignment, which is a sustainable material for the construction industry for ECS246. The journal that we have chosen, it has been published on February 24, 2016. The author is Dr. K.N. Said. His email is drkn.sid@aiim.ac.in. He is a Director Operation, Adani Institute of Infrastructure Engineering and Management, and Dean of Interdisciplinary Research at Gujarat Technological University.
This presentation concludes the introduction, method, result, discussion, conclusion, and reference.
Fly ash is a byproduct of coal-fired power plants and is a fine grey powder made up primarily of spherical glassy particles. Pozzolanic characteristic in fly ash allow it to interact with lime to produce cementitious compounds. It is frequently referred to as an additional cementitious substance. Over 65% of fly ash generated by coal power plants is dumped in landfills and ash ponds worldwide. Outdoor ash storage or disposal can eventually cause harmful chemicals to seep into aquifers of groundwater. Fly ash generally enhance new concrete by lowering the amount of water needed for mixing and enhancing paste flow characteristics.
The methodology started with the design of the concrete is calculated using the concrete mix design table. Second, the aggregate, fly ash, and water are weighed based on the calculated design. Third, all of the materials are being mixed in the mixer. Fourth, the concrete mixture was tested with slump test. Fifth, if the condition is satisfied, the cement mixture will be compacted in the mold. 6. The concrete mixture will be left for 24 hours until it completely dry. 7. The concrete then will be left soaked for 40 days and 24 days respectively. 8. The concrete will be tested with compression tests on the day 14 and day 24.
Fly ash. For as far back as some decades, the utilization of fly ash in building development had a great track record. The performance benefits that fly ash provides to mechanical and toughness properties of brick have been recently inquired and recorded in real structure. Aggregate. For fine aggregates, typical natural sand obtained from Lauran Seper was utilized in saturated surface dry conditions in entire blends. The coarse aggregate used in this study was obtained from Margala in saturated surface dry condition and was used in all blends. The maximum size of coarse aggregate is 30 mm. Tests were performed to determine aggregate physical parameters.
Fly ash creates a denser product because the size of the pores are reduced.
This increases strength and reduces permeability. Fly ash improves workability and produces the same workability with less water. The reduction in water leads to improved strength because fly ash contains larger or less reactive particles than Portland cement. Concrete can recycle fly ash from coal-fired plants and slag from the blast furnaces of steel production, but this material may contain toxins like mercury. The toxin should not be directly exposed to occupant. Indigenous fly ash for partial replacement of cement as an admixture for concrete have already been successfully. In India, 10% of ash is utilized in that construction and landfilling. 3% is used in other industry. Thus, it has been successfully shown that fly ash can be utilized in major infrastructural projects. Others use of fly ash. Fly ash is suitable raw material for a variety of products and may be utilized for the production of Portland pozzolana cement using fly ash as pozzolana, precast fly ash concrete building unit lime fly ash, soil stabilization used for road and airfield pavement construction. It can also be used as fill material in embankment construction and as a filler material in bituminous concrete. The advantage of fly ash are: first, eliminate carbon emission; second, save topsoil; third, source of all the year-round employment; fourth, prevention of dumping of fly ash in ponds.
In conclusion, the project task that we have presented in this video is related to the use of fly ash as a cement substitute and has proven its effectiveness as a concrete mix material. Furthermore, fly ash also has many uses and many advantages of its own. However, fly ash also has the disadvantage that it may contain toxins such as mercury. So, the decision to replace cement with fly ash was one of the right decision. This is because it can eliminate carbon emission as well as prevent the disposal of fly ash in the pond. Therefore, we can reduce air pollution as well as water pollution in our country.
Here are the list of references that we use while we are completing our project task. That's all from us. Thank you. Bye.